Okay, good. So now we are so many members present here. We can start the class on statistics. Am I audible? Am I
Yes,
audible to you all?
yes, sir.
Am I audible to you all?
Yes, sir.
Okay.
Yes, sir.
Hello. Acha. One thing. So in statistics, we are going to cover MPC-006. That is statistics in psychology. And today I will try to cover the unit 1, unit 2, I mean two booklets. That's introduction to statistics and correlation chapter. So before telling about statistics, I must tell you frankly that most of us have a fear towards statistics because statistics involves calculation, mathematical formulas, all these things. But statistics is really very easy actually if you go through that very carefully. So statistics, the paper uh, is actually developed to measure about population parameters, to discuss, to tell about population. So the word came from statistia. So basically now statistics is dealing with three, four aspects. First of all, it's collecting data, data collection, data organization, data analysis, data interpretation, data presentation, all these things. So statistics is a study linked with data. So you use statistics to deal with data. And data, data comes through information from different sources. And this data has to be dealt with through statistical approach. And the statistics, as we deal with, that broadly differs in two categories. One is parametric statistics, other is non-parametric statistics. And as you know, the parametric statistics is a better method, better system, having more reliability, more power, is more powerful than non-parametric. And the parametric statistics has its own assumptions. And here, in parametric and non-parametric statistics, when we divide the statistics into categories, we divide this basing on some uh, points. For example, the about distribution, regarding distribution of data, scores, and also about the scale used, or about the structure of or model fixed, and also about the other things like the how it is distributed. So all these things decide that the statistics will be parametric or non-parametric. Usually in statistics, we deal with a sample to tell about a population. So you all know about population. Population is a very vast concept. Suppose now there is going to be the election in Bihar. So we want to know that what is the opinion of the Biharis regarding the party, for example, BJP or Congress or this Janata Dal, like that. So it's not possible to ask all the people in Bihar. Very difficult. Not only time consuming, but also very effort consuming, very painful. So we actually take a sample, a small group. So this on the sample study, sample survey, we predict a result. During election, there is some survey, exit survey. Different survey is there. Exit, we say exit poll. That is your sample. So sample is taken from a big population because study on population is not possible. So here we only take a group, we select a group from a big population, and this group may be selected randomly. And here in this sample, we presume that the distribution is randomly done, or there is randomness. So if the distribution is there, like a normal distribution is there, then you can say the parametric statistics can be applicable. If there is no such distribution clearly mentioned, whether it is normally distribution normally or not normally, so then we go for non-parametric. So non-parametric statistical test is a less powerful test than a parametric statistical test, but it is more used because it is very easy and also very already almost available quickly by taking any test to decide about the result. The non-parametric statistics can be ensured that the data is not normally distributed. When the data is not normally distributed, when the data is collected through some methods like rank methods, like scales like ordinal scale or nominal scale, the data collected. So the nature of distribution, nature of scale used, that or the structure of or the model or the way you are going to take it. So all these things are telling about the applicability of a test like a non-parametric test. When the data is indicating normal distribution or normal assumption of data, or the method is used like interval scale or ratio scales, higher scales, then usually we think of applying parametric statistical test. So the non-parametric statistical test, the parametric statistical test, these are the two types of tests we use in statistics to analyze the data and to make a conclusion. So as I told you earlier, it's not possible to take a big population. So you take a sample, and for the sample point, sample view, sample conclusion, we just generalize about the population. So since the sample view is approximately mixing, tallying with the population, when it is normal distribution is ensured, then we can safely conclude that the sample conclusion will be the conclusion of this population, or it will be the sample points can be referred to as parameters. But when it's not normally distributed, then we cannot ensure that the sample conclusion will be like a parameter. So now the population index is called parameter. So the sample dealing with any population index, any population measure, we say it is going to tally with parameter or not. We are able to describe about a parameter or not. So if the sample is perfectly drawn, if the sample is randomly drawn, if the sample is a big sample, and the sample is taken in a very correct method, then naturally we can ensure that the sample findings can tally with parameter or population finding, or sample conclusion will be that of the population, or from a sample view we can generalize, we can say about population. Similarly, as I told about the survey exit polls in Bihar or any other place, so any poll view can really predict about the election, provided the view has been taken, the survey has been taken from a right sample. So therefore, sample taking is very important, and from the sample we can make a conclusion about the population. So now these two methods are used to tell about the sample statistics, and from these two type of tests, we always try to make a conclusion about the population. So now, as I told you, the non-parametric statistics is a very, very more used, and also here we take inference from this. And the non-parametric statistics, as you know here, as I told you, it is distribution of free method, or here it is used in rank or any nominal or ordinal scale, but the parametric statistics are used in higher scales, and the non-parametric statistics are actually including different types of tests, like you see, this test could be, and then your chi-square, it could be any type of test which is not very power test. So T test, F test is a very powerful test. They belong to parametric statistics, whereas these are the chi-square or the Manute test or the there are so many tests. Also, I'll tell you later. So these are actually used in non-parametric test. So the as I told you, there are four types. You see, the parametric test is used when the sample is large. Because in parametric test, we always say that here there is normality assumed. This means population is well represented in the sample. So the parametric statistics is possible when there is the size of the sample is larger, or the n number of cases. N means number of cases is very large, and when the n is small, then we are having no other option except using non-parametric statistics. And the as I told you, the parametric test includes T test, F test, and these tests are quite robust and also quite appropriate when some assumptions are not made. So now here we are coming to the scales. As you know, I told you the lower scales, I mean nominal scale, ordinal scale, could be used in non-parametric statistics test, and the other scales like interval scale and decimal scale, they are used for parametric statistics. The nominal scale is the lowest category scale, which deals with the only data which is classified like some nominally classified. A data is supposed to classify like male, female. So we can say whether the male is better than female or like that. A category indicating. So the such categorical scales are nominal scales. Suppose we give in ranks or in order. For example, suppose you are having a 3-point scale: happy, more happy, or moderately happy, more happy. When you give this gradation like this, when the order is indicated, any 3-point scale, 5-point scale, the order is given more or less, or you can give a rank also. When there is a rank in the data, we are dealing with the ranks. We are not getting the scores, but the data is given in rank, in order. So now that is called ordinal scale. And here, in this case, we are only using the non-parametric statistical test. And the interval scale, as you know, is a higher scale, and here this is a constant scale, but having no natural zero. So here, this data includes, for instance, we can say temperature in centigrade or Fahrenheit. The we can say that the interval scale possesses 2 out of 3 important requirements of good measurement. For example, magnitude is there, equal interval is there, but lacks the absolute zero. But you can get this absolute zero when you are measuring the weight or height. uh, when measuring the height, weight, age, length, there we get the zero. But when you do not get zero, we are not getting the zero, real zero, I mean absolute zero. Only we get the gap. So here we use the interval scale. So interval scale is a good measurement scale. We here get the magnitude, we get the constant scale indicates the differences. So the data will say indicate difference, but not the real zero, not the real natural absolute zero. But still then, this scale, interval scale, is a more reliable scale, and it tells about the data, about getting the data in a reliable manner. Or you can say the interval scale is used reliably in data collection. So the ratio scale, the highest order of scale, is having all these qualities also with the zero or the absolute zero. As I told you, the height scale or the weight, height, age, all these things. So now we use these scales, and in the non-parametric and the parametric statistics, we use the scale in a differential manner. Usually, non-parametric statistics are being that the scales used as ordinal and nominal, and parametric statistics use scales as interval and ratio. And also, as I told you, the parametric statistics, the n is high. N means the number of cases in a sample is quite more because it is approximating to population. Therefore, we say that normally, if the n is 30 or more, then we can say that parametric statistics could be used. And if it is less, then non-parametric statistics is better to be used. And here, as I told you, the we can say that the uh, unlike parametric statistical test, we can use non-parametric statistical test where the data is measured in ordinal or nominal scale. Nominal scale also called as categorical scale. So nominal scale has another name, categorical scale. So data could be used in nominal or ordinal scale, that is for non-parametric statistics. Secondly, non-parametric statistics deals with small sizes. When the n is small, when sample is having less numbers, then non-parametric statistics could be better used. And here, thirdly, the non-parametric statistics are used when the data is not bound by any assumptions. As I told you, when you assume the data is normally distributed, the score is normally distributed, if there is any assumption like that about distribution of data or score, then that links to parametric statistical test. But here in non-parametric statistical test, no assumption involves. And also, lastly, the non-parametric statistical tests are very user-friendly compared with parametric statistical tests, because non-parametric statistical tests are simpler, easier sometimes also, and could be used anytime with any data. So it is a more popular type of statistics that we are using through, and that is all non-parametric statistical test. So now something you see, parametric, non-parametric, and the metric, parametric, non-parametric. That means a parameter, and a parameter is something, a term about population. Any population term, population index is called parameter. So both the statistics are trying to tell about the population. And non-parametric is also from the data we can say about population, and the statistical conclusion from parametric statistics also speaks about population. So hence, you can say that since the parametric method is using better scale, using more number of cases is indicating normal distribution or assumption. Then the parametric statistics better tells, better describes, or more dependable when it is going to conclude about population. So when you are going to use a parametric test, the data we get in parametric statistical methods, and you analyze this, we make a conclusion, and this conclusion can be safely generalized for the population measure, or this conclusion can be used as a parameter. This sample finding could be as good as a parameter. That is as good as a parameter means this could tally any population measure. So here, now I can say what are the assumptions? Are the assumptions of parametric and non-parametric. So almost as I told you, the parametric statistics are using the t-test, f-test, and these tests can satisfy the following conditions. For example, the population from which the sample has been taken should be normally distributed. And here, normal distribution means it will be distribution will be following a normal curve, which is infinite at both the ends. Normal curve means the curve is not touching the baseline, infinite. That is asymptotic. And the variables involved must have been measured in interval or ratio scale. And also, the variable and its type could be having different values. The type of variables could be dependent variable or variable considered to be an effect or independent variable. So the observation must be independent. The population must have some variance, or in special cases must have a ratio variance. We call it homoscedasticity. So the variance will be there naturally. There will be ratio variance. This means homoscedasticity. The samples have equal or nearly equal variances, and the condition is homogeneity variance. So also the observations are dependent. So now see, when the data is normally distributed, or the variables measured in interval and ratio scale, and the variables could be of different types or different values, and the variables could be dependent variable or independent variable, and independent variable, and dependent variable is the result, and independent variable is the cause. As you know, in laboratory experiments you have seen that. And also here, apart from that, there you will find also there is observation. The observation must be independent. You are observing something, is independent because it's not linked to anything else. The observation is independent, and most interestingly, there is homoscedasticity. This means there is a known ratio of variance. The data sometimes you are getting in one sample, the another sample data varies, but there is a ratio of variance. So the other also homogeneity. This means there is equality or homogeneity of variance. They vary in some degree, homogeneity of variance, and they vary with the ratio homoscedasticity. So these are there, the assumptions on which you can take a parametric statistical test. So there is homogeneity, there is homoscedasticity, there is independent dependent variable, there is interval ratio scale, there is assumption about normality. So these are there means the assumptions are complied. So you can use parametric statistical test. If these assumptions are not there, then we can use non-parametric statistical test. And the non-parametric statistical test, as you know, the assumption here is this: the distribution is not normal, the distribution indicates small size or some small sample size. I told you less than 30. And the scale is also like nominal scale or ordinal scale. So these are the assumptions. With these assumptions, you can decide whether you will take a parametric test or non-parametric test. So since these two tests are there at our hand to deal with data, now we can discuss which test or which type of statistics is more reliable, more applicable, which you can take more. So now let me take first in non-parametric statistics. I told you it is very easier also. We can do with any data is small cases, small n, sample is small, we can use. Then here the non-parametric statistics has some advantages. Number one, when the sample size is small, there is no alternative except using non-parametric statistical test. So the advantage of non-parametric statistical test is that it can be used if the data is small. Number two, so non-parametric statistics have fewer assumptions about data. Non-parametric statistics depends on fewer assumptions. So also in non-parametric statistics, the hypothesis tested may be more appropriate for research investigation. Also, the non-parametric statistical method can be used frequently or easily with numerical scores having the strength of ranks. Non-parametric statistical methods also available to data in a very classificatory way, like using nominal scale classification category, and also samples made up of observations from several different populations at times cannot be handled by parametric test but can be handled by non-parametric test. So non-parametric statistical test is typically easier to learn and apply, and also the interpretation is often more direct than the interpretation in parametric statistical test. Therefore, the non-parametric statistics has an upper hand, or you can say it has more advantages in comparison to parametric. But still then, it has some disadvantage. With regard to disadvantage, so here the data is not assuming normality. So when you are going to tell about a population, it will be less powerful. And here the parametric statistical test is more powerful in that way. And also here the table used is in different formats. These tests they are scattered widely. The tables used for non-parametric statistical test is scattered widely, but in parametric statistical test the tables are specified. So here, in some aspects, parametric statistical tests or measures are more usable when you speak about the population, or you speak about the reliability of our conclusion or generalization, or you speak about the power of a test. So here, then you come to parametric statistical test. As I told you, the parametric statistical test approaches to population because the size of n is large, and here the samples taken from the population are, if the population is large and randomly taken, and also if the samples may not be identical, but they are not very much different because they are taken randomly. And here we can say that the samples taken in parametric statistical test, the sample means they surround the population mean. There is a theory called central limit theorem. This means the sample means they surround the population mean, and there involves a sampling error. And this sampling error will not very much vary from sample to sample. There will be sampling error, but not will vary so much. And here the means of the samples will be, here you can just see that there are 3-4 conditions where you can get the parametric statistical test into use. Number one, the means of the samples will be normally distributed. The average value of the sample means will be same as the mean of the population. The distribution of sample means will have its own standard deviation. The standard deviation is known as the standard error of the mean, which is denoted as the SEM or sigma mean. It gives us a clue as to how the sample means may be expected to deviate from population mean. The standard error of a mean tells us how large the errors are in any particular sampling situation. And the sampling error indicates the deviation of sample mean from the population mean. So now see, these terms may be very hard for you to remember and understand also. But one thing you remember here, we have a population. Example I am giving about the Bihar election. So suppose Bihar is a big state and we are going to take survey. We want to apply parametric statistical test. So we randomly took 4-5 samples, one from its capital, the other from other 2 very commercial places, and one from the rural places, like that, randomly. So randomly we took the persons per survey from the Bihar population. So now see, so here the means of the sample, we are taking 5 samples, one from capital, one from urban, 2 from urban places, 2 from rural places, and 2 from very commercial places, or 2 from minority places, like that. So now see, in all these samples, we are having a mean. We get data in sample, we get a mean. And these means we get from 5 samples, they will not be very different. They will be different, but not in extreme form. And those means will be naturally around the population mean. Suppose population mean is, suppose BJP is getting 120. The survey mean came 120 BJP and 60 JDU and Congress 10, like that, something. Suppose it came. Now you'll find that is the mean, population mean, what you get in the end. But a sample will find that may be 120, but a sample mean could be 110 or 100 or 105, like that. Not very extreme form. If 120 comes as the mean, the sample mean cannot be 5. No extreme difference. So this means the sample is drawn randomly. Therefore, sample mean would be more or less like that of population mean. Or you can say The sample means any population means. If you take their mean, it will be called as standard error of means, because due to some sampling there may be some error. I mean, we say standard error, and when these means are taken on the population mean, or this mean difference with the population mean, we say standard error of mean. And central limit theorem tells that the samples means will be around the population mean, and the differences will be standard error of means. This means sample means will approximate with population mean. That is there in parametric statistical test. So here, this distribution, I mean, could be applicable in t-test, f-test, as I told you, and a parametric statistical test is used in a very, very emphatic way in using t-test. And t-test, as you know, you must have done t-test. T-test is the difference, testing the difference between two means. So there are two samples, or a sample mean and population mean. When two means are there, we want to test whether the means are different or not. If there is a difference, this difference is a significant difference or a chance difference. So to this we use a t-test, and t-test is the test measuring or indicating significance of the difference between means of two samples, two independent samples, large samples. So here the t-test could be used in large samples, and here the standard of the mean of the first sample, standard of the mean of the second sample, from both the standard error we can get the standard error of mean, and by applying formula we can find out the t value. But when we are not taking two big independent samples, suppose we are taking two dependent samples, two matched samples. For example, you see, suppose you appeared exam half yearly and then appearing exam annual. Now question is, the mean of your half yearly performance is different from the mean of your final test performance or not? If the difference is there due to chance, or it is a significant difference. For example, in half yearly examination you read very well, you did a good marks, good score. In annual, suppose you fell ill, could not do well, and now the difference is there. So now you have to analyze. You say the difference is significant or due to chance. So here, this test is actually dependent sample, because this same person, same group, tested in half yearly, again tested in annual. So it is a type of, say, matched pairs, matching sample, repeated sample, or you can say two dependent sample. So these values are also measured or tested, and the significance, whether the difference between the means is significant or not. So always the method to get the t value is sample mean 1, mean 2. So mean 1 minus mean 2, the difference between two means. The difference between two means divided by standard error of mean. That's the formula. And that formula also is applicable here. And here in dependent sample, since they are dependent, maybe matching or related, we can say related samples. So we find out here index of their correlation or their correlation measure of correlation is indicated, and from that we can use that index of correlation in finding out the standard error of means. But the same method is same like mean 1 minus mean is 2 by the standard of mean. By the formula, we can use the formula to get the t value, and you can test the t value whether it's significant or not. There is difference because means are different, there will be difference. But this difference in mean is significant or not, that can only be used for testing, and we should know whether this difference is significant or not. And here we could also do this testing of difference between two samples and more samples. When in two samples, two means are compared, we usually go for t-test, Fisher scale t-test, and the t-test is indicating whether the difference between two sample means is significant or not. But now the question is whether we can make the t-test applicable for three groups, or when the samples are more than three or more. Then here, in case of more than two, we usually go for F-test. F-test, you know, is the analysis of variance. And the F-test, here we take this F-test. F is a measure of variance also, largest variable is smaller variance. And from this F-test, it has its own method of measuring. And here we get the between errors, within errors, total errors, total sum of all these things. So then we get from that the F value, and also we test the F value whether it's significant or not. So T value, F value, which are coming out of parametric test, they are to be tested whether they are significant or not. If significant, then we can make a safe conclusion that both the samples, suppose two samples are taken for giving an opinion, and again I'm coming to the Bihar election. Those two groups have been taken. In one group, the result came, the NDA will sweep the election, will come with a thumping majority. In another group, the mean came differently, like this other group will come, Mahagathbandhan will come with a majority. Now the question is, now these two are differing. So this difference is there. So now we can test whether the difference between the means is a real difference or chance difference. So if it is different, if the possibility is 95% or more, then you can say it's a real difference. Or if it is less than that, we say it is a chance. Means maybe the members in a sample selected not randomly, it is a biased sample. Maybe that in one sample the people are taken from different categories. The second sample, the people are taken from one minority group. Result is obvious to be different. So when the sample is taken not randomly, or the sample is a biased sampling, then the difference could be possible. So now we have to get the t value, get the f value, and then we test it whether these values are significant or not. So if significant, then at what level? In a 0.5 level or 0.1 level, highest level. 0.1 means 99 cases. We can say with 99% guarantee, or you can say with 95% guarantee. At what level? So, statistics is such a thing where the significance level is always used at 95 and above. Suppose you say in 80% cases it is different, not acceptable, a chance. So we only accept even 95 and above. So now we can say with that level of significance, we can say whether the result is both the samples or both the group's findings are different statistically significantly or not. And usually the you can go to central limit theorem, as I told you earlier. Usually, since both the samples are taken from the same population, and if taken randomly, then it is now a possibility, or you can say that both the result will be almost same, or the means will not differ so much. There may be difference, and the difference may be only a matter of chance. So because they are selected randomly. So now this test, parametric statistical test, by using these T test or F test, could tell about the the population measure, population finding parameter perfectly, correctly. And here this parametric statistical test is also sometimes used in cases of Pearson R, or you can say the coefficient of correlation. There you can say also whether they are related or not related. If related, with what percentage? It is chance case or it is a significant case. Suppose two persons related, or exam half yearly, exam final, they are related. Not different. So, or you can say the view of the father and the view of the son may be related. So the relationship, any index, of relationship, or you can say the coefficient of correlation, Pearson's coefficient of correlation, which you find in the sampling distribution or in samples. We can also test it, and we can say that we can get the significance, and we can say that whether these two samples they are related significantly or not significantly. So this way, the parametric statistical test can be used in D test, F test, sometimes also like this R test, Pearson's coefficient correlation, also some other higher tests. There are so many higher tests also where this can be used. Now we can come to non-parametric statistical test. The non-parametric statistical test also can be used for getting conclusions about some findings. So this also tells about the parameters, about some population measures. And here, from non-parametric statistical test, most frequently used non-parametric statistical test to draw statistical inferences in case of unrelated or independent samples. 3-4 studies are there. One is chi-square test, the other is the median test, and third is Mann-Whitney U test. These three tests are called non-parametric statistical test. The chi-square test, you must have heard the name of the chi-square test, and the chi-square test is not a measure of degree of relationship. Rather, you can say it is a test of independence, and it is a test to estimate the likelihood that some factor other than chance account for the relationship. If there is any relationship, the relationship is something other than chance. So here, the chi-square test evaluates the probability that one observed relationship results from chance or the real difference. So the chi-square test is also measured in the way like statistical significance, and we can say it's significant or not significant. So chi-square test is very popular test. Many social social surveys, social studies, or social findings you can see there could be involving chi-square conclusions. So like chi-square, there's also median test. There's another test, median test. So if the samples from the population are having been drawn with similar or same median, then you can also take this median test when you can put the data in a combined way and get the median, and then we divide these cases in two groups, row and column wise, two into two ways, and then you can find from the combined median the higher median values, lower median values. Then you can make the other two groups compared. So median test is also another type of test where we can speak about the differences, whether significant or not, between two groups or two samples having medians. And thirdly, man-Whitney U test is more useful than the median test. One of the most useful alternative to parametric t-test. In a parametric statistical test, we are using t-test. I have told you about t-test and f-test. In a parametric statistics, we are using t-test. But in non-parametric statistics, we can use man-Whitney U test. And man-Whitney U test is applicable when the scores or the result has been measured through ordinal scale values, nominal or ordinal scale values. So now here I have told you about this ordinal scale, and when the ordinal scale values are used, then man-Whitney U test is also very relevant. And we can say whether two means are different or not. It is significantly different or not significantly different by using the non-parametric man-Whitney U test, which is an alternative to parametric t-test. Also, there are some other non-parametric tests for related samples like sign test, where we use only signs like more or less or like plus or minus. On the signs, we could find out the differences. The underlying assumption is that the variable under the investigation has a continuous distribution. So we can say whether it is more or less. So from these signs like less or more, plus or minus, we can find out whether they are two different or not. And lastly, we can also have a Wilcoxon pair rank test or paired sign rank test, which is a better test than the sign test. And here we pair the ranks, and also we get the test findings by using the method or the formula. So this way we are using this method like parametric statistical test and non-parametric test to deal with the data and to give conclusion about the particular finding. So now I come to another unit 2, the descriptive and inferential statistics. So statistics could be of two types. The methods, I know, I told you earlier about the methodological differences, parametric and non-parametric. And statistics can be used in two ways. One is the method as a data, another method. So when you say statistics has been used, that means method indicating singularly. And the statistics shows in data, that is plural. So statistics, the term can be used singularly, can be used plurally, in a plural way. Singularly can be used as a method and plurally can be used as a data. So we now could describe about parametric, non-parametric when you use statistics as a method. Now I come to the data matters, the descriptive and information statistics. When something describes about the data, we say it is descriptive. So here the descriptive statistics and the information statistics, they have two different purposes with regard to the use of statistics. So the observations that we do or the observations, so the scores you can find, they are subject to variability. Suppose human behavior, lot of observation, lot of variability. So it is all known that the attitude, intelligence, personality that differs from individual to individual. There is individual difference, and in order to make a sensible definition of the group or to identify the group, it is necessary to express this observation in a precise manner. So here this can be used basically in two ways. One, data could be used in organizational matter or way that the organizational data, that you can say the organization of data, or you can say the summarization of data. So organize, summarize. So now when you organize the data could be of four different ways. First of all, classify the data, then tabulate the data, then graphically present the data, then diagrammatically present the data. The classification could be indicating the arrangement of data. So here it could be classified as the frequencies. Once the data collected, they could be used for a conclusion. So you can put in a frequency form, frequency distribution, and the frequency distribution there, like on group data, group data. So here the distribution are different also. And when you construct a frequency distribution, there are three methods. One is exclusive method, the other is inclusive method, the third is the true or actual method. For example, in a group data, you are going to use a class, internal class. For example, 5 to 10, 10 to 15, 15 to 20. Now see, in all the cases, 5 to 10, 10 to 15, 10, 10. Last 10 in 5 to 10 group, and first 10, 10 to 15 group, common. So here, this means, so one is exclusive. So here, the last here is excluded when you count the next. So 5 to 10, 10 to 15. This means 5 to 9, 10 is excluded. 10 to 15 means 10 to 14, 15 is excluded. So the last one is excluded. That is exclusive group. There is another inclusive group. This 5 to 10, you write 5 to 10, 10 to 15, 15 to 20 like that. Or you can write 5 to 9, 10 to 14. So 5 to 9, that is inclusive method, because you include all the members here. 5 to 9 all included. And suppose you make this like 5 is according to limit 4.5 to 5.5 is 5. So 5 starts with 4.5 and 9 ends with 9.5. So 4.5 to 9.5. That is actual. That is called, you can say, for the 30 to 40. Without write 30 to 40, you can write 29.5 to 39.5. This means this is the actual class method. So here the frequency distribution, as I told you, could be in two ways: exclusive method, inclusive method, or true or actual method. And here The types of frequency can be distributed in relative frequency or cumulative frequency. Cumulative means all added. So this could be relative frequency distribution, or this could be frequency cumulative frequency distribution, or this could be cumulative relative frequency distribution. So like this, we can distribute the data in frequency distribution. Then you can tabulate the data. We go for tabulation. So here we can put this in a tabular form. So we can give the title of the table. We can give a caption. We can give the head note, or you can give a footnote, or you can give a source of data. That is tabulation. That is, you are tabulating data in a tabular form. Then you can put the data in a graphical presentation. So you can put this data in either histogram form. Histogram means when you draw the graph on lower limits, or you can do on frequency polygon. So either a lower limit, or from the midpoint, or from the upper limit, like frequency curve. So here, or the cumulative frequency curve upper limit. So now here see, from the data, you can draw the graph either from lower limit, or from the midpoint, or from the upper limit. So you can make a graphical presentation of the data. So like histogram, like frequency polygon, like frequency curve, like cumulative frequency curve, or ogive. So these are all presenting data. And also, lastly, we can present data not only through curve or graph. Also, you can put it in diagrammatic form, like bar diagram, or you can do like pie diagram, circular, pie diagram, or bar diagram, or subdivided bar diagram, like this. So we can put this data in that way. So that all indicates organization of data. Now I come to summarization of data. What is summarization of data? So data cannot be appreciated if only organized. It should be summarized also. Summarization. So summarization means, so from the data you must get something summarized. So here, either you get the data in a presentable form, like we get the data in tabulation, we got the data on a representation in a graphical form. But in research, we require comparison between two or more series. For the comparison, this tabulation of data is not sufficient. We require to investigate the characteristic data. So the frequency of distribution obtained in the data may differ in two ways. First, in measures of central tendency, and second, the extent of its spread or variability. The data we have got, you want to see what is the measure of central tendency. We are not going to deal with all the data. We want to deal with the measures of central tendency. Or also, the data, we get a central tendency value, then we want to know the spreading, how much these scores are spreading or deviating on the same center. For the two aspects. So one is the measure of central tendency, and secondly, the extent to which scores are spread over this central value. So now you see, we got the data, we get the data organized, you get it frequent distribution, we get it tabular form, we get it diagram, all these things. But now the question is, you go for summarization. Means you have to put the data, you can deal with the entire data, you put the data in a very concise form, like get the central value. and that is central value is central tendency. And again you see that whether these scores are spreading around central value or in extreme form. Suppose the mean is suppose 60. So you are expecting that the score should be 40 to 70, 60 mean. But you can't expect the score will be 5, extreme score. So 5 means the spread is very high. There is more variability. So now you want to get the data central value and also the spread value. And here, while dealing with central value, we are going to get 3 central tendencies. One is arithmetic mean, which is commonly said mean. Secondly, median. Thirdly, mode. And mean is the widely used measure of tendency, which is commonly known as the average of data, total minus number of cases. And median is the middle value or the midpoint dividing half up. And in the extreme values, in the extreme case, median are not affected. In the extreme case, mean will be affected. The mean is taking the average of all, mean will be affected, but median not affected. It is the middle point. And mode is the most frequently appearing value. That is about the measures of finite tendency. And method of dispersion or spreading or method of variability, there could be range one is the one with simplest method of dispersion. Range that's the gap between the lowest score, highest score, and average deviation. It is the average of the deviation of the score from the mean, irrespective of these signs. Then standard deviation, and here we take the scores, deviation scores, and you square it by squaring the minus plus signs are neutralized, and from the square you take the square root, then you get the standard deviation. It is the most stable method of tendency. So all these measures are range, AD average deviation or ST standard deviation. They are indicating dispersion of the data. And next we come to skewness and kurtosis. Skewness also indicates the symmetry of the distribution. If the frequency distribution are more concentrated, then we can say it's less skewed. Or if the distribution of data points is concentrated at one end or the other, then we say it is skewed. So it is skewed left side, right side. So we can say positive skewed, negative skewed. Skewed means concentration on either side, not in the middle. Similarly, kurtosis is pickedness or flatness of the frequency distribution. If the data of the distribution is the curvedness or the pickedness of the graph, and here if the distribution is more peaked than normal, we say leptokutic. If it is less peaked, it is a platykutic, or flat-like is a platykutic. And the normal curve is called as mesokutic. So like this, we find that in this descriptive statistics, we find that these things are coming, that we describe, we get the data, we collect the data, we tabulate the data, and we summarize the data, we get the frequencies with respect to their central measures, and also we get the variability or dispersion of data around the central values. Now we come to the other point. Statistics is two types, I told you in the beginning, descriptive and inferential. Now I come to inferential. So inferential statistics means we are giving some conclusion. We give inference to this. Inference means conclusion. So we deal with the data, descriptive. Now we analyze the data, we give a conclusion, we give a finding, and that is inferential. So organizing and summarizing is one step in the process of analyzing the data. And now, after that, we come to analysis, where from we get the statistical inference by making conclusion. So here we can the inferential positions or the inferential statistics is the mathematical and logic of how the generalization from sample to population can be made. We are taking a sample and how, with what logic we can say that this finding is applicable to population. That logic, that mathematics is coming under inferential statistics. And this inferential procedure or the inferential statistics could be of two types. One is estimation, the other is hypothetical or hypothesis testing. So estimation could be inference is made about the population, about on the basis of the sample, on the basis of the finding on sample. So there may be sampling variations without chance fluctuation or sampling errors. And estimation about population characteristics may be influenced by those factors. You will now see, because if the sample is not drawn randomly, if it is biased sample or biased sampling, then there will be more sampling error. And due to sampling error, then the estimation about population will be wrong, will be influenced. So the estimation, the important point is that to what extent our estimate is close to the true value. So what is the true, how far we are estimating truthfully, that is estimation. So the characteristics of the good estimator has following characteristics, like unbiased. It should be unbiased. It should be consistent, means repeatedly same thing. It must be accurate. So unbiased, consistent, and accuracy, they are the three important characteristics of good estimator. And unbiased means, this is a common thing I need not explain. So only consistent means repeatability or probability of repetition. And accuracy means how accurately you have found out. So the point estimation, the interval estimation, so all indicates how closely you are approximating to the reality of result, or how your conclusion is approximating to population parameter, or how truthfully you are able to estimate your values. And also the other way is hypothesis testing. And in the statistics, very relevant and important thing is hypothesis testing. So hypothesis is something like prediction or foretelling about the results before you start an experiment, or before you start speaking something about behavior or any conclusion. You make a pre-telling, or you can say foretelling, or you can say prediction, and that prediction is called hypothesis. So here, when you say something will happen, or you can say this time this will win the election. That is the, suppose now I will ask you, who will, by the way, are you all able to hear me properly? Hello?
Yes, sir. Yes, sir.
I am going on, statistics is a very difficult portion. And if you like, I can take a pause to discuss also. I am now oriented to finish the portion, 3 chapters. But about discussion, if you like, because sometimes you will have some doubts, and with the doubt you cannot go up further. So tell me, whatever I have told till now, are you clear? I told you many things. Like I told you, I told you the type of tests. Also, I told you about the distribution. I told you parametric, non-parametric. I told you how they differs. I told you how it is used. I told you their assumptions. I told you again the statistics, two types, descriptive, inferential. How descriptive two types, organizational and summarization. How inferential two types. So that I am telling. So could you just get idea about that or any problem? So hypothesis testing is very important. So before I go for that, I must know whether you are clear or not. I am asking about Nimisha. Somebody is Nimisha here. Nimisha, are you clear? You are here, Nimisha, clear?
Yes, sir, I'm here.
Oh, good. Nimisha, from which place you have come?
So basically, I am from NCR, but right now I'm staying in Bhubaneswar.
Oh, good. Oh, I'm happy to see that you are all reading psychology. And Khanap Prabhav, you are clear?
Yes, sir.
Oh, Khanap Prabhav, you are from Odisha, I think. Which place?
Yes, sir. Jajpur.
Nagpur. Sandhya, you are here, you are clear?
Yes, sir. Yes, sir. Clear.
Oh, good. Shatabdi, clear? Shatabdi, are you clear?
Yes, sir.
Oh, she is not clear. She is having delayed response. Delay means not clear.
No, no, sorry. I am clear.
Asa Kiran Kumar, how are you?
Yes, sir. Fine, sir.
Fine. Where from you are?
Basically, sir, I am from Bargod, but now staying in Bhubaneswar, sir.
Oh, good. So, are you clear? Okay, Johnny. Johnny, you, how are you? One name Johnny is there. Oh, not here, but name is showing. Anyway, so I am happy that all are you saying that you are clear. Even if doubts there, you are bypassing the feelings and supporting how to complete the course. Good. So now see, anyway, statistics is really difficult, and you can, if any doubt arises, you can ask me. I will give you my number at the end. You can take my number also. If you do any problem, any doubt arises, you can ask me and clarify. Right. So after the class, I will take 2-3 minutes. We will have personal discussion, so doubts can be clear. No problem. So now see about hypothesis testing. So before you start something, either you go for experiment or either you go for making any comparison or you go for a prediction. So beforehand, you just make a view about that. That the hypothesis, I know, as I told you, is a foretelling. Suppose I ask you to have a hypothesis, to have a prediction, who will win Bihar? What do you say? So the hypothesis must be also rational. Kiran, I'm asking you. Kiran, I'm
I
asking.
propose hypothetically maybe NDA.
NDA. So now see how there's no maybe. It's hypothesis. So it's a prediction. Yes, NDA will
Yeah,
come.
yeah,
So,
yeah. Sorry,
so you
sir.
can.
Yeah, no predict,
So
no maybe.
so you can. You are saying this because. So you are saying this because. So when you are making a hypothesis, you are not making only simply simple guess. You are looking the background factor. You are looking at the background factor. For example, you are seeing whose meeting is more crowded, or people are coming voluntarily to which meeting. So looking at that, you are making a conclusion, one prediction. Is not it? So
Yes.
now sleeping in the bed and saying this will happen, like this, the astrologer. Is not. So here, hypothesis. is not something like procrastination. It's something like prediction. And prediction is also rational. Could you get me or not? So here, in the hypothesis testing, when you make hypothesis, you go by probability. So statistically, or a statistical hypothesis is a statement which may or may not be true. But we wish to validate on the basis of sample information. We have got some information about a sample and we want to say on that. Right? So here, now the question is, suppose you guessed that NDA will come out successful. So your hypothesis or your prediction is governed by governed in two ways, governed by two conclusions. Maybe that it may happen, it may not happen. So now here, when it is happening, so we can say that my prediction is correct. So I am able to predict correctly. So suppose not happening, you say what? I predicted well, but due to chance factor, this could not be materialized. Isn't it? So sometimes chance factor also operates. So here, the probability of chance occurrence also come. So accordingly, hypothesis we take in two ways. One is null hypothesis, the other is null alternate hypothesis. I will say the ladies and the gentlemen, or the boys and girls, they differ in their intelligence. So now, if I ask you to make a hypothesis, almost all of you will say that the boys are different from the girls, or maybe more intelligent, or maybe more skillful. Something more like that. But now you see, but when you count the result, the reverse happened. The girls became more intelligent, girls became more skillful, girls threw better. So what happened? So now, here, two hypotheses. The first null hypothesis, null means no. No difference. First of all, you start like this. Boys and girls, they will have no difference. The null hypothesis. And if difference, then boy will be more or girl will be more. So alternative hypothesis is something, first of all, in hypothesis testing, you all say that there will be no difference. Why no difference? Because the two samples belong to same population. There can be no difference. Or the two samples belong to two different populations. There may be difference. So now, we should see if there is a difference or not. If there is a difference, the difference is by chance or significant. If the difference is, suppose the boys and girls are comparing, the difference is significant at 0.05 level, means 95% level, then you can say there is real difference. But if they are different in 90% level, not 95, 90% level, 0.1 level, out of 100 in one cases, like that. So in 90 cases, even if they are different, you cannot say they are different. They are not significant. Chance factor operating. So chance factor and significant factor. That is now the count. If chance operating, then we say that there may be difference, but it's not a real difference. But if the difference is significant, we can say that this difference is a real difference. Right? So the hypothesis tells about the significance of the result, and the significance is measured by different level. So that is, one is 95% level, I told, that is 0.05. So when the P means probability is less than 0.05, then we can say it is significant. Or less than 0.01, it is highly significant. So this means, now see, we start with this view that there is no difference. If the probabilities P is more than 0.05, this means 95 cases there, you can say there is no difference. Null hypothesis is appropriated. But it is less than 0.05, we say null hypothesis is not applicable. Null hypothesis is failing. So alternate hypothesis is acceptable. So the label we fix like 0.05 or 0.01. So then we test what label the difference is there. So that is, you remember. So if P probability is more than 0.01, then no difference. If less than 0.01, there is difference. So 0.01 means 99 level, or more than 0.05, no difference. Less than 0.05, less means probability of no difference is less than 0.05. This means there is a difference. Could you get me or not? We always comparing, or always we are going to give conclusion with respect to the null hypothesis. So when the null hypothesis fails, then only we say there is difference. Similarly, there is also another way of, that is called one-tail test or two-tail test. So suppose you can, if in the curve, you know, there is a normal probability curve. So at both the sides, you know, from the very zero, you go to the other end, the positive side, zero to left side, negative side. So we can say that if you are comparing, you was, suppose one person, one child was depending only on mother for its food. Now the child is getting mother's food, getting these other nutrition foods, and getting all these things. Now see, so getting one food, now getting more health care. So the direction is there. So naturally, when getting more care, more food, then what you are expecting, it will definitely be better. You cannot say it will be less. So the prediction gives indication about the direction. Then it is a one-tail test. You can say less or more. But if it is, when you say you do not know, it may differ, may not differ. As told by someone told me that there may be different, NDA may come, may not come. So may and may not. This means positive, negative side, both sides, two-tail test. But only when you say there will be difference, and the difference will be significant or not, I don't know. Like this, increasing food habits or better health care, all these things. So here, one-tail test. So one-tail test means that is going on one side, and here the level of significance in two-tail test is 0.05, in one-tail test half of that. So actually one-tail test and two-tail test there to make conclusion about that. And the errors of hypothesis testing, when you make a hypothesis, we test it to the level of significance and by using the one or two-tail test. And we have some errors also in hypothesis testing. The errors are two types: type 1 error, type 2 error. So when the null hypothesis is true, but we reject it. When the null hypothesis is true, for example, we are giving a test in the classroom. Although the boys and girls differ. The null hypothesis says There is no difference in boys and girls. But marginally you found that there could be a difference significant. So what you are saying? So you know boys and girls are having no difference. But you say there is a difference now, you found it. So here, what you say? The null hypothesis is rejected. There is no difference rejected. So now we reject the null hypothesis and accept the alternate hypothesis. So here what happened? The type 1 error. We know boys and girls, they have no difference. Because sometimes boys are having better marks, sometimes girls have different marks. Even in national scenario, girls are doing better than boys. But with this result, you cannot say, even if you find the result is significant, difference significant, and you are rejecting null hypothesis. But if you know it is true that there is no difference, that is type 1 error. For example, so when the null hypothesis is rejected, but actually it is true, you got type 1 error. And the other thing is this, when null hypothesis is wrong, null hypothesis is false, there is difference, but you say there is no difference. For example, about the what I can say about the skills of people. You know, some people are better skilled. For example, the parent, the father is a teacher. The parents are teachers. The parents are doctors. Parents are lawyers. Then you can say their children may be better than other people also, that they are comparatively better. So the null hypothesis is false. There is no difference. We say there is no difference. Maybe false. But you accept it. But you have to say that they are all equal. In a society, for example, Brahmin and the other caste also like Sudras, you can compare about their caliber, skills, efficiency. Or suppose you about the puja karmas. In some temples, non-Brahmins are there, Brahmins worshipping, non-Brahmins worshipping. So suppose you make that, there's no difference. Or there's no difference in worshipping, no difference in doing practice, no difference in teaching, no difference. So that is it. But despite there is a difference, we say there is no difference, then that is type 2 error. Where null hypothesis is true, but you are rejecting type 1 error. Or null hypothesis is false, but you are accepting, that is called type 2 error. And there is a power of test. The power of test indicates the significance of the test. That is also very important. But now you see here, all these things are very important. A type 1 error, type 2 error, one test, two test, level of significance. So that is all about hypothesis. Then you come to the next one. Type 1 error, type 2 error, that is also done here. I'm not going to repeat that. Then this type 1, type 2 error is a big chapter. And here, this hypothesis testing considers the probability. And here, making conclusion is very important. So when you are concluding about one hypothesis or speaking on the hypothesis, you should be very careful that such errors are not coming up. And also, I am coming to the other portion of the level of significance. So when you put the level of significance for discussion, as I told you, the alpha level is 0.05 or 0.01. That you have to also see. And here, as I told, the null hypothesis and alternate hypothesis. Null hypothesis represents null hypothesis indicates always there is no difference, no anything null, any null means no. So here the errors coming. The hypothesis is true, but we reject. Type 1 error. Hypothesis is wrong or false, we accept. Type 2 error. Hypothesis true and we accept. Is a correct decision. Hypothesis false and we reject. Is a correct decision. So type 1 error, type 2 error, very important also. So it is all about this. Then actually we come to one person, that is confidence limit. So when we accept one hypothesis, so we have to make, or we have to compare the probabilities under some confidence limits. The limits within which the hypothesis should lie with specified probabilities are called confidence limit or fiduciary limit. It's customary to take the limit at 5% or 1% level of significance, as I told you earlier. If sample value lies between the confidence limit, the hypothesis is accepted. If not, the hypothesis is rejected. Generally, 0.05 and 0.1 level of significance are the most popular limits taken in social science research. But sometimes we have to compromise that also in other types of studies. So here, how to find out this standard of mean is given here. Standard of mean, I told you, standard of mean, that is indicating the sample difference from population, sample mean differing from population mean. And here, when you set the level of confidence or significance, you also see the size of sample, and you know when the size of sample is 30 or less, we have to make correction. And also 212 to 112, as I told you, these are also you compare. Within 112 test, the level will be that double of the 212 test. So example here also you can take it from the book also given. So I need not go in detail. So here I just complete this unit 1, the first booklet. Then I come to second booklet. That is coming as correlation and regression. So now we are going to correlation, right? Are you all comfortable? Hello? We are going to correlation. Can you go to correlation?
Yes, sir.
Yes,
Sir.
correlation. Say correlation indicates correlation, combined relationship. Or correlation indicates the relationship between two persons, two variables. And the correlation, for example, you can say the person who is intelligent can also perform better, because you say performance and intelligence, they run hand in hand because they are correlated. So we can say from the correlation, we can predict. If two things are correlated, we can predict one from the other. So the relationship can be indicated in linear way. It can be indicated in a scattered way. So in scattered diagram, we can say that is scatter diagram or scatter plot is one way to study relationship between two variables. Here to plot pairs of values of subjects on a graph, and then you see how the graph is directed. This Scatter diagram depicts relationship between intelligence and engineering tasks given in the book. This indicates the person who is intelligent will be more reasonable. So the Scatter diagram indicates a clear-cut relationship, and the correlation becomes linear or non-linear. One of the basic form of relationship is a linear relationship. Linear relationship can be expressed as a relationship between two variables. Like me put in a straight line. So this means, for example, intelligence and reasoning or intelligence performance. You can make a linear relationship. Straight line, you can say the more intelligent, the more performance. There may be also non-linear relationship. It could be curvilinear or non-linear. There is one Yerkes-Dodson law. Yerkes and Dodson, they found a very interesting finding. You are having the idea that if you are having more the stress will decrease your performance level. Is not it? You are having the idea that stress will decrease your performance level. It's a common idea. But actually, Yerkes and Dodson, they found that stress is not always decreasing performance. To increase the performance, some stress is required. So they said the relationship between stress and performance not linear, it is curvilinear. So performance is poor when the stress is too little or too much. This means when the stress is very less, no stress, then performance is poor. The stress is very high, then performance is poor. So with optimum stress or moderate stress, the performance becomes better. So this is type of indicating not non-linear relationship. So linear means one-to-one. Non-linear means it is curve-like. So thus the relationship could be linear or curvilinear or non-linear. Similarly, the relationship could be direct or directional or non-directional. So directional correlation could be positive or negative. So if are increasing, both are increasing. Intelligence increasing, reasoning increasing, positive. But one increasing, other decreasing, negative. So it could be, for example, intelligence and error. IQ increasing, errors decreasing. So error and intelligence, they are having negative correlation. And intelligence and performance or reasoning, they are having positive correlation. So positive means in one direction, that is going upwards, and negative means so they are having relationship with universe. And here also one reason is one indication hope increases, depression. There is line here in the book. As hope increases, depression decreases. It's true. When you are having hope, then you are having life. Then depression will decrease. When hope increases, depression decreases. This means hope and depression, they are negatively correlated. So here the correlation indicates the strength of relationship, and the correlation strength or the strength of relationship is measured by the term correlation coefficient, and the correlation coefficient is actually indicating the strength of relationship between two variables. And sometimes we find when both the things are having a relationship, both are covering a common area, and the variance, that you say the variance of the common area of relationship involving the both variables, that is indicating covariance. So covariance and the correlation, they are also very much connected, similar also. Actually, we want to measure the correlation in different ways. The one way to measure correlation is when the variables are in continuous distribution, continuous. You know, the scores are in a continuous form, discrete series, continuous series. Their score is continuous, means, so for example, we are going 10, 11, 11.5, 12, 13, a continuous scores. But there are some number of fans, number of chairs, they are not getting continuous. They are actually, so here you see, suppose there are 3 fans, suppose there are 4 fans in 3 rooms. Suppose you take a average number of fans. Can you say the average is 4 by 3 fan? No. So some numbers are round numbers, some are continuous. So you can say that there is, when the distribution, you can have some discrete series, some continuous series. So the score is continuous. So when the score is continuous, or one variable is presented in the continuous form, or data is in continuous series, then you can say the Pearson R, or product moment coefficient correlation, is very much applicable. And here the R, or product moment correlation, gives you an idea about covariance also. The covariance divided by the standard deviation, it gives the value of coefficient of correlation. And here one thing I want to tell you, the significance of coefficient of Pearson's coefficient correlation, by significance of testing in Pearson's correlation coefficient. The 2%, one is Pearson, other is Spearman. Pearson has given a measure of relationship that is called Pearson's R, and Spearman has given also measure of relationship, that is the rank difference correlation. And here in the Pearson coefficient correlation, you can find out that the two significant thing, that the scores are in a continuous series, but when the scores are not in continuous series, we don't go for this coefficient correlation. And in coefficient correlation, we have a particular method. We from the standard deviation, we just get it. So here in coefficient correlation of Pearson, we actually try to see that different values of correlation can be obtained between two variables. The researcher is not only interested in knowing the finding in the specific time sample, they are also interested in estimating the population. Testing of the significance of correlation is also a very complex issue. So it has to be checked with T distribution or Z distribution to find out the significance of the R. So taking the degrees of freedom. So suppose you are getting the R significance testing. So the number of cases minus 2 becomes the degrees of freedom. Each pair you are comparing, So there are last pair is 2 persons involved, so minus 2, n minus 2. That is the degree of freedom. With degree of freedom and specific table, you check whether this finding is significant or not. So here the other way of getting the significance of the correlation is also like other types of correlation. One is phi coefficient. So one thing we'll find here in the correlation coefficient, there are some assumptions. So the assumption is that interdependence among the pairs of scores will be there. Then only go for the Pearson R. The population of X and the population of Y follow the normal distribution, and the pairs of X and Y are the normal bivariate distribution. That should be there, so that you can apply the Pearson R. And here sometimes the measurement is there is some unreliability in the measurement or unreliability of the measurement because of outliers. Outliers are extreme scores. Because of extreme scores on one of the variables or both the variables, the presence of outliers determine the block the impact, or they affect the correlation value. So the outlier indicates extreme score. Also curvilinearity. The Pearson's product moment correlation is appropriate if the relationship between two variables is linear. In case of curvilinear relationship, it may not be appropriate. So when this coefficient correlation not appropriate, we have also the other methods, other types of correlation. So one is phi coefficient. Here we can see point bisexual correlation. We can see phi coefficient. We can see bisexual correlation. We can see tetrachoric correlation. We can see rank order correlation. We can see Kendall's tau test. There are so many type of correlation methods, and very interestingly, when there is, suppose we are comparing two pairs, when one of the pair is presenting continuous variable and the other pair is showing dichotomous variable, not continuous, then we can apply point biserial correlation. I am giving an example. Suppose you have taken 20 persons, out of which you are having 10 males, 10 females, or 9 males, 11 females. So now in one case, you are taking male, female, sex-wise, dichotomous, two types, male, female. That is male. The other variable is their examination mark. So marks in examination is continuous, but sex, that is not continuous. That is dichotomous. So the marks of male, marks of female, being compared. And here we are going to see the relationship between males or sex and marks. Whether the sex has a relationship on the performance or not, we are going to see. So one side, in one way, you are having males, that is dichotomous variable, males and females, dichotomous variables. In the other side, we are having performance or exam mark, that is only continuous variable. So one is continuous or the dichotomous. In that case, you can apply point biserial correlation. And the formula is given in the book. You can find out there also. The significance of testing also is given. You can make the test significant. There is also another correlation, phi coefficient. The phi coefficient is still the other way. Both are dichotomous. Now see, the biserial correlation point, one dichotomous, other is continuous. In phi coefficient, both are dichotomous. For example, in the property of the house, who is being owner, male or female? So now see, dichotomous, male, female, ownership, owner, not owner. Dichotomous. Then no continuous series. Then no continuous like mark, no variable not continuous like mark, like height, like any type that's continuous. No continuity there. Only dichotomous. When both are dichotomous, males and right to property. Right to property, yes or no? Sex, male or female. Sex, dichotomous, right to property, dichotomous. So dichotomous and dichotomous. In these pairs, relationship being estimated, that is called phi coefficient, PHY. Then another is simply not point biserial correlation, only biserial correlation. Here we can find the biserial coefficient, biserial correlation coefficient. It like point biserial correlation, but in point biserial correlation, as we discussed earlier, one variable is dichotomous and do not underlie continuity, but the other variable is having continuity. And here in biserial correlation, here the variable has underlying continuity but measured dichotomously. Then the biserial calculation calculated. So now see, in the biserial correlation, you see it's like a point biserial correlation, but in point biserial correlation is computed while one of the variables is dichotomous, having no continuity. But here the variable has continuity, dichotomous but having continuity. Then having it is biserial correlation. Then you come to another correlation, the tetrachoric correlation, when both the variables are dichotomous. And both the variables are dichotomous and also having underlying continuous distribution. For example, I'll give an example. Attitude of males towards liberation, attitude of females towards liberation. And liberation is a positive negative attitude. There is continuity. So both the dichotomous, liberal attitude, yes or no, sex, male or female, both are dichotomous, but having continuity. So now here, I can say that the variables here may be dichotomous, but having underlying continuity. Or females, attitude to females, for example, attitude to females and attitude for liberation. So now you see, suppose you are seeing attitude to females and attitude to liberation. Both are having underlying continuity. The attitude is a continuous variable. So now, in that case, we are having tetrachoric correlation. So, excluding all these, there is another correlation which is very important for you, that is the rank order correlation. And when in the rank order correlation, we are getting the data in ordered form, and here when the assumptions do not satisfy Pearson correlation, we go for rank order correlation, that is Spearman's rank order correlation, and the formula is, as you know, 1 minus 600 sigma difference square by n into n square minus 1. You know the formula, very easy also. And here this the data is in the rank, and like this we are having another type of rank difference correlation, that is Kendall's tau, and this Kendall tau is a better test actually. And here also another is a useful method of correlation, the alternative to Spearman's law or rank difference correlation, and the tau also indicates the significance. And like this, we are having also, you are having other correlation like partial correlation, multiple correlations, and here we are having regression. So regression, linear regression, or only regression, and regression gives you also prediction about. You can have prediction in statistics. You can have a prediction about one's personality, about their behavior by taking the regression equations. Regression equations will help you. So the multiple or the partial correlation, regression correlation, they are also there. So all these are the methods which helps you to predict the relationship, to predict the one behavior in the context of another variable. So, of course, the time is over. I think time is over. Hello? The time is over. Hello?
Yes, sir.
Why so? It's over, isn't it? Anyway, so we now stop it. I have briefly covered. I know you must have many doubts in mind also, because these type of correlations simply the Pearson's R and the Spearman law or rank difference correlation is the two convenient methods of correlation, and you are all very known to this. And actually, in these two correlation techniques, either coefficient correlation of Pearson or Spearman, they can tell you the index of relationship, but there are other type of data are available where these two tests may not be better indicators. There only you use other types of biserial or Kindle or any multiple correlation. So you can go through the books. Then if in doubt arises, you can ask me, and you can tell me if any doubts are having. For 1 or 2 minutes, I could take to just clarify if some doubts were having. By the way, all of you must be knowing me also. I hope you all know me. Yes or no? No reply. All are gone or what?
No, sir, we are here. Hello.
You know me or not?
Sir, we were not present in the yesterday class. Sorry.
Oh, listen. You do one thing. You are the first year students, is not it?
Yes, sir.
You are first year.
Yes, sir. Yes, sir.
Yes, sir, we
Okay.
all are first year.
Right, good. So you are a very young people. In first year, though many persons are reading, staying in service also. One is for career building, other is routine career, other is for interest only. Psychology very interesting, so you have to read psychology to have a degree only. There are many thoughts in that way. So primarily people are coming to read psychology for degree or for just to have an interesting subject knowledge or some career making in your particular service. What is that? Or coming for some clinical counseling. So many people come for different purposes. Basically, I was a science student long back in 67, 68. I came to psychology just to psychology, something like reading mind, very interesting. So I came to psychology just because it was interesting. I do not know whether I did well or not, whether decision was good or not, but I was doing very well. Otherwise, there in my original discipline, I was doing very well. But I came here just out of interest. And by the way, I have completed almost like 52 years of teaching. And you are probably the 53-year batch I'm teaching in your PG classes. So basically, I was principal of so many colleges, retired for the last 16, 17 years. And I am also teaching in your IGNOU courses. Now the thing is, typically there are doubts and many students, they are not able to get it clarified. Even by reading the books, they are not able to understand also. And specifically in statistics, the doubts are not easily solved. So in the other portions, you can read again and again, you can be clear. But by simply reading again and again in statistics, you cannot be clear. So you have to take some views from a teacher of somebody. So for me, you are so small people, smaller than my expectation also as I look. So you are free to ask me anything. Bhagyasri, you are from whose place? Jaspur.
Sir, Bhubaneswar.
Bondhe ରହୁଛ କୋଉଠି ନିଜ ଘର?
ହଁ ଏଠି ପାଖରେ ମାନେ ଉତ୍ତରା ପାଖରେ।
ଆଚ୍ଛା। ଅମିତା, you came later. ଅମିତା କୋଉଠି ଆସୁଛ? ଅମିତା?
Hello. हाँ sir.
You are from which place?
अच्छा sir, गंजम.
ଗଞ୍ଜାମ?
हाँ sir.
ସମସ୍ତେ ଆମ ଓଡ଼ିଆ ପିଲା ତ? ଅଲଗା ଓଡ଼ିଆ, ସମସ୍ତେ ଓଡ଼ିଆ ପିଲାଟି?
ଆଜ୍ଞା sir।
କିଏ ନନ୍ ଓଡ଼ିଆ କିଏ ଅଛି କି?
Sir, Nimisha was non-Odia. She was not able to understand Odia in our last discussion. Probably she is not right now there.
ଯଦି କିଏ ଓଡ଼ିଆ ଲୋକ, ମାନେ ମୁଁ ବେଳେବେଳେ କହିଦଉଛି ଯଦି ଓଡ଼ିଆ ଲୋକ କିଏ ନେ ମତେ ବୁଝେ, either Hindi or English I have to speak and I must be reminded, right? ଶୁଣ ତୁମର ସବୁ listen, ମୁଁ ଏଇଟା ତ ପଢେଇଲି ଆଜି ତରବରରେ ପଢେଇଲି. I did not justice to the course because I was in hurry, because we were given to complete the portion within 2 hours. And also again we have to take on 25th and 26th. There in that period you can ask me, or else if you like you can clarify by taking my phone number. I am giving a phone number also. You can note down. You can ask me any doubt if any doubt arises. I am 98610 32210. 98610 32210. That's the number.
Thank you.
If anybody have any doubt, can ask me. I can clarify in a very cool way, And again telling, statistics is very, very easy person. It is very, very easy. Because you are having fear. You are not able to follow quickly. You love statistics. It will love you. Right? So, you read the book. Whenever you do not follow, you ask me. So, can we take farewell? Can we just leave it? Can I
Thank you,
close it?
sir.
Thank you,
Okay.
sir.
Thank you.
Okay, welcome. Will you see? Will again
Thank
see?
you, sir.
Will again meet on 25th? Right?
25th, I
Yes.
think.
Yeah.
26th. Not
25th,
25th.
26th.
2 days probably. 25th, 26th. The 2 days.
Yes, sir.
2 days. 25th, 26th.
Hmm.
Okay. We'll again see. I'm waiting to see these charming faces again. Thank you all.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.